Hello there, and welcome to Boring Planet. Tonight we're going to spend some time with something that lives quietly alongside us, something so familiar that we often forget how strange it truly is. A kingdom that doesn't move quickly, doesn't ask for attention, and doesn't need to be understood all at once. Mushrooms. They grow at the edges of our awareness, on forest floors beside fallen trees, sometimes even between cracks in the pavement, appearing briefly and then fading again, as if they were never there at all. For most of human history, we didn't quite know what to make of them. They didn't behave like plants, didn't move like animals, and seemed to follow rules of their own. And yet, while we were busy naming stars and mapping continents, mushrooms were already doing their work, shaping the soil beneath our feet, recycling what had ended, and quietly holding ecosystems together. If you enjoy these slow explorations of science and nature, you're welcome to like or subscribe or share a thought in the comments. It helps others find their way here too, one curious listener at a time. But for now, let's begin. Mushrooms belong to a hidden kingdom that exists almost entirely out of sight. What we notice, the caps and stems that rise briefly from the ground, are only the smallest visible signs of something much larger. Beneath forests, fields, and even cities, vast networks of fungal life spread slowly through the soil, weaving around roots, stones, and grains of sand. These networks don't hurry. They don't waste effort. They respond patiently to the world around them, sensing moisture, temperature, and chemistry, waiting sometimes years for the right moment to act. Long before forests covered the land, before animals walked on solid ground, before humans learned to shape tools or tell stories, fungi were already here. They helped turn bare rock into soil. They prepared the land for plants to grow. They built the foundations for life, on Earth as we know it today. And they did so quietly, without leaving monuments or traces that demand attention. Even now their work continues beneath us, unnoticed, uninterrupted. Fallen leaves disappear not because they vanish, but because fungi slowly take them apart, returning their matter to the soil. Dead trees soften, collapse, and become nourishment for new growth. Nutrients move through underground pathways, linking one organism to another in ways we're only beginning to understand. To walk through a forest is to walk across a living system that is far older and more interconnected than it appears on the surface. Mushrooms remind us that life doesn't always announce itself, that some of the most important processes on this planet happen slowly, invisibly, and without spectacle. They don't compete for space the way animals do. They don't reach toward the sky like trees. Instead, they spread outward and inward, forming networks rather than towers, connections rather than boundaries. There is something quietly comforting about that. In a world that often feels rushed and loud, mushrooms follow a different rhythm. They wait, they adapt, they respond only when conditions are right. And perhaps that's why learning about them feels less like gathering information and more like noticing something that has always been there. As we move through this story, we'll wander through forests and across ancient landscapes, through kitchens and laboratories, through moments measured in seconds and others measured in millions of years. You don't need to remember names or details. You don't need to follow every idea to its end. These facts are meant to drift by gently, like leaves carried along a slow-moving stream. Some will catch your attention, others will pass without leaving a trace. Both are part of the experience. Mushrooms teach us that stillness is not absence, that waiting is not wasted time, and that connection doesn't require visibility. Beneath every step you take, beneath roads and buildings and open fields, the quiet work continues, threads spreading, matter-transforming, life-supporting life. And as we begin this slow journey through the hidden world of mushrooms, you may find that the planet feels a little calmer, a little deeper, and a little more alive than it did before. For most of human history, mushrooms sat quietly in the wrong place in our minds. When early naturalists tried to make sense of the living world, they relied on what could be seen with the naked eye. Things that reached toward the sun were grouped together. Things that stayed rooted were assumed to belong to the same family. Mushrooms growing from soil or wood seemed to fit well enough among plants, and so they were placed there without much argument. It felt reasonable. They didn't walk, they didn't hunt. They appeared where the ground was damp and shaded, just like moss or grass. And for centuries that assumption went mostly unchallenged. But appearances can be misleading, especially when life operates on a scale we rarely notice. As tools improved and scientists began to look closer, mushrooms began to reveal habits that didn't quite align with the green world they'd been grouped into. Plants, for instance, make their own food from sunlight. Leaves spread wide to catch light, transforming air and energy into living tissue. Mushrooms do nothing of the sort. They don't reach for the sun. They don't rely on light at all. Instead, they take in nutrients from their surroundings, absorbing them from wood, soil, and decaying matter. This difference may seem small at first, but it changes everything about how an organism lives. The deeper researchers looked, the more obvious the mistake became. At the cellular level, mushrooms told a different story entirely. Their cells are reinforced with chitin, a tough, flexible substance also found in insect shells and crab armor. Plants rely on cellulose instead. This single detail placed mushrooms closer to animals than to anything green and leafy. It suggested a shared ancestry far back in time, long before forests took shape, long before animals developed bones or nervous systems. Mushrooms, it turned out, were not strange plants at all. They were something else entirely. Even their breathing revealed this hidden kinship. Like animals, mushrooms take in oxygen and release carbon dioxide. They rely on the same basic chemical pathways to extract energy from their food. Plants, by contrast, use sunlight to split molecules apart and build sugars from the air. This quiet exchange, happening constantly and invisibly, repositions mushrooms in the story of life. They are not passive decorations on the forest floor. They are active participants in the same metabolic dance that sustains animals, including us. For a long time, this truth remained buried, not because it was especially difficult to uncover, but because there was little reason to question old assumptions. Mushrooms were not central to agriculture or medicine in most cultures. They appeared briefly and vanished again. They were easy to overlook, easy to dismiss as minor curiosities. And yet, while human attention drifted elsewhere, mushrooms continued doing what they had always done, shaping the planet from below quietly and persistently. Once this misclassification was corrected, the world began to look subtly different. Forests were no longer just collections of plants rooted in soil. They became layered systems, with visible life above ground and vast interconnected networks below. The soil itself stopped being an inert substance and started to feel alive, threaded with organisms that didn't belong to the categories we were used to thinking in. Mushrooms occupied a middle ground, neither plant nor animal, yet deeply connected to both. This realization invites a gentler way of seeing the familiar. A mushroom growing beside a path is no longer a fragile plant struggling in the shade. It is the brief appearance of a much larger organism, one that has likely been present in that spot far longer than any tree nearby. What we see above ground is temporary, almost incidental. The real body exists elsewhere, spread thinly through the soil, responding to changes we cannot sense, waiting patiently for the right moment to emerge. That patience is one of the defining traits of the fungal world. Mushrooms do not rush to grow. They do not waste energy on constant visibility. They remain hidden for most of their lives, expanding slowly, adjusting quietly, sometimes persisting for decades before producing a single visible structure. When they do appear, it can seem sudden, almost magical. A patch of ground that looked empty the day before becomes dotted with caps and stems overnight. But this apparent spontaneity is an illusion. The work began long ago, out of sight, progressing at a pace that has nothing to do with human schedules. This way of living stands in contrast to how we often imagine success or survival. Plants race toward light, animals compete for food and territory, mushrooms invest in connection and chemistry. They spread rather than stand tall, they dissolve rather than conquer. Their strategy is not about speed or dominance, but about endurance and adaptability. They don't need to be noticed to thrive. It's easy to see why such organisms slip through the cracks of early understanding. Human attention gravitates toward motion, brightness, and scale. Mushrooms offer none of these reliably. They are quiet. They are soft. They blend into their surroundings. Even when they are colourful, their presence is fleeting. And so, for generations, they remained peripheral to how we understood life on land. Yet, the longer scientists studied them, the clearer it became that fungi were not side characters at all. They were foundational. Without them, nutrients would remain locked in dead matter. Forests would suffocate under their own debris. Soil would lose its fertility. Life above ground would falter quickly. Mushrooms and their unseen networks perform work that no plant or animal can replace. They are specialists in transformation, turning endings into beginnings over and over again. There is something quietly comforting in that role. Mushrooms do not create waste. They do not leave behind unusable remains. Everything they encounter becomes part of a cycle, broken down and redistributed, returned to forms that other life can use. In this way, they embody a kind of patience that feels increasingly rare. They accept what is given. They work with it. They wait. Recognizing mushrooms as members of their own kingdom doesn't just correct a scientific error. It softens the way the world feels. It reminds us that not all important work is visible, that some of the most essential processes happen slowly and without recognition. It suggests that complexity doesn't always announce itself with grandeur. Sometimes it hides in plain sight, mistaken for something simpler than it is. As this understanding settles, the ground beneath us seems less solid and more alive. Each step crosses over networks we cannot see, organisms we misnamed for centuries, lives unfolding at a pace far removed from our own. Mushrooms, once mistaken for odd plants, reveal themselves as something deeper, older, and more patient than our categories ever allowed. And as we continue moving forward, this sense of hidden depth will only grow, carrying us gently into the unseen body beneath the forest, where the true scale of the fungal world begins to unfold. Once that misunderstanding begins to loosen, once mushrooms are no longer seen as strange plants but as something entirely their own, it becomes harder to look at a single mushroom and believe that it tells the whole story. The cap and stem feel suddenly incomplete, like a clue without its context. What looks like a small, delicate life above ground begins to feel more like a signal, a brief surface event marking the presence of something far larger and far more enduring below. The true body of a fungus does not rise into the air. It spreads through the earth. It exists as mycelium, a living network of threads so fine that they slip easily between soil particles, so thin that thousands could pass through the eye of a needle. These threads do not grow upward or outward in dramatic gestures. They extend slowly, quietly, following gradients of moisture and nutrients, adjusting their direction by fractions of a degree over time. The movement is so gradual that it escapes notice entirely, even when it happens directly beneath our feet. Mycelium has no fixed shape. It does not begin at a single point or end at a clear boundary. It branches, reconnects, and overlaps with itself, forming a flexible body that can thin in one place and thicken in another. Where food is abundant, it becomes denser. Where resources are scarce, it stretches outward, exploring patiently until it finds something usable. There is no rush in this process. Days and weeks pass without visible change, but the work continues all the same. What we recognize as a mushroom is only produced when the mycelium has gathered enough energy to justify it. This decision is not conscious, but it is precise. Temperature, humidity, and seasonal patterns all play a role. When conditions align, the network redirects stored resources toward a single purpose, building a structure designed to exist briefly and then disappear. The mushroom emerges, releases its spores, and collapses back into the cycle that sustained it. This makes the visible mushroom less like an individual and more like a moment, a temporary arrangement of tissue created to solve a specific problem. Once that problem is solved, the structure is no longer needed. The mycelium remains, unchanged in its deeper continuity, extending its reach and maintaining its quiet presence beneath the surface. It is difficult to overstate how much of a fungus's life passes without being seen. In some cases, a network may exist for years before producing a single mushroom. In others, it may never produce one at all. The absence of visible growth does not mean inactivity. Beneath the soil, enzymes are being released, organic matter is being broken down, nutrients are being absorbed and redistributed. The work is constant, even when nothing seems to be happening. This hidden persistence is one of the reasons fungi are so successful. Protected from sunlight, wind, and sudden temperature shifts, mycelium exists in a buffered environment. It is less vulnerable to the rapid changes that affect life above ground. When drought dries the surface, moisture may still linger below. When fire sweeps through a landscape, the underground network often survives, ready to respond once conditions improve. Because mycelium is spread out rather than centralized, damage to one part does not mean the end of the organism. If a section is disturbed or destroyed, growth simply continues elsewhere. There is no single point of failure. The body is resilient because it is distributed. This way of living stands in quiet contrast to organisms that rely on specialized organs or fixed forms. Over time, as the network grows and adapts, it becomes increasingly efficient. Paths that consistently lead to nutrients are reinforced. Less productive directions are abandoned. The result is not random sprawl, but a living pattern shaped by experience. The mycelium remembers its environment in the only way it needs to, by adjusting how and where it grows. This slow intelligence does not require a brain. It emerges from countless local responses, each thread reacting to what it encounters. The coordination arises naturally, without oversight or command. In this way, the fungal body operates more like a landscape than a creature, more like a process than a form. It exists by continuously responding to its surroundings, neither resisting nor controlling them, but working with what is available. When rain falls after a dry spell and mushrooms appear seemingly overnight, it is tempting to think of them as sudden growths. but the truth is far less abrupt. The mycelium has been there all along, waiting. The rain does not create the fungus, it simply gives it permission to reveal itself. What looks like spontaneity is actually patience finally rewarded. This patience reshapes how time feels in the fungal world. Growth is measured not in moments but in seasons. Progress is not marked by visibility but by continuity. The mycelium does not hurry toward an outcome. It persists, adjusting quietly, confident that conditions will eventually align. This confidence is not optimism. It is adaptation refined over hundreds of millions of years. To imagine this hidden body beneath familiar ground is to soften the boundary between what is alive and what is not. Soil becomes less like a surface and more like a living medium, filled with movement too slow to see. Even places that appear empty or still may be threaded with fungal life, extending gently through spaces we assume are inert. This perspective invites a different kind of attention. Instead of looking for what stands out, it encourages noticing what continues. Instead of focusing on growth that demands recognition, it highlights processes that endure without it. The mycelium does not need to be seen to function. Its success does not depend on visibility. It simply remains, adapting quietly to whatever the world offers. In this way, mushrooms offer a reminder that presence does not require appearance, that something can be deeply alive without ever announcing itself, that the most influential parts of a system may be the ones we never notice directly. As this understanding settles, the mushroom above ground begins to feel less like the subject and more like the trace, a sign left briefly on the surface by a body that exists elsewhere, operating on a scale of time and space that unfolds entirely out of view. Beneath every step, beneath every fallen leaf and tangled root, the work continues, slow and uninterrupted, shaping the conditions that allow everything else to grow. In some places, the underground body of a fungus grows so large and persists for so long that it becomes difficult to describe it using the same language we apply to most living things. Words like individual, organism, or even body begin to feel imprecise. The network does not occupy a single location. It does not have a center that can be pointed to. Instead, it spreads outward slowly, adapting its shape to the land itself, following moisture through soil, moving around stones, slipping between roots, extending wherever conditions allow. What appears above ground as a scattering of mushrooms across a hillside or forest floor can, in reality, be the surface expression of one continuous being. Each mushroom shares the same genetic identity, each one connected through the same underground threads, all part of a body that has been growing quietly for centuries. The separation we perceive is an illusion created by the limits of our vision. Beneath the surface there is continuity. In one forest, scientists discovered a fungal network that covers several square miles. It is estimated to be thousands of years old. The trees growing above it are younger by comparison. Some of them have lived only a few decades. Others may reach a few centuries at most. The fungus beneath them was already present before the oldest of those trees took root, and it will likely remain long after many of them fall. It does not compete with the forest for dominance. It supports it by existing alongside it. The growth of such a network is not dramatic. There is no surge, no visible expansion. Year after year, the threads extend by small increments, responding to the availability of nutrients and water. Where the soil is rich, growth thickens. Where it is poor, the network thins and reaches outward. Over time, these countless small adjustments accumulate into something vast. The idea of size becomes strange in this context. The fungus is not tall, it does not loom, it cannot be seen from a distance, and yet, by area and mass, it may outweigh the largest animals on Earth. Its presence is spread thinly across the land, making it easy to overlook and difficult to comprehend. It is large without being obvious, ancient without appearing old. This way of existing blurs the line between organism and environment. The fungus does not sit on the land, it inhabits it. Soil becomes part of its body, roots become pathways, fallen wood becomes nourishment. Over time, the distinction between what belongs to the fungus and what belongs to the forest becomes less clear. The two systems merge into one continuous process of growth and decay. Human time feels sharp by comparison. We measure years in calendars and lives in milestones. We notice beginnings and endings. Fungal time moves differently. There is no clear moment when the organism begins, only a gradual expansion from earlier growth. There is no single end point, only contraction here and extension elsewhere. The network persists, not by resisting change, but by flowing with it. A fire may pass through the forest above, burning leaves and blackening trunks. For many organisms, this is catastrophic. For the fungal network below, it is often survivable. Insulated by soil, protected by depth, the threads remain intact. When new plants begin to grow in the cleared space, the fungus is already there, ready to connect, to support, to continue its work as if the interruption were only a brief pause. Floods, droughts, freezes, and thaws all come and go. The mycelium adjusts its activity but rarely disappears entirely. It slows when conditions are harsh. It accelerates when they improve. Over centuries, this adaptability allows it to outlast changes that would erase more rigid forms of life. The organism does not need stability. It needs only the ability to respond. Because these networks persist for so long, they become quiet witnesses to the land's history. They do not record events the way humans do, but their structure reflects what has happened. Areas of denser growth may mark old river paths. Thinner sections may trace places where soil was once poor or disturbed. The body carries the memory of the land in its shape, written slowly in living threads. Standing above such a network, it is easy to feel small, not in a way that diminishes, but in a way that settles perspective. Human lives unfold quickly. Our concerns feel immediate and pressing, and yet, beneath us, a living system operates on a scale that makes urgency seem temporary. The fungus does not hurry to adapt to each change. It simply continues, confident in the long view shaped by deep time. This deep time also shapes how the fungus interacts with other life. Trees growing above these networks are not isolated individuals competing alone for survival. Their roots are entwined with fungal threads that extend their reach far beyond what they could manage on their own. Water absorbed in one place can be shared elsewhere. Nutrients, released by decay, travel through the network and reappear far from their origin. In forests supported this way, resilience increases. When one tree struggles, others may indirectly support it through the same fungal connections. When conditions vary across the landscape, resources can be redistributed, smoothing extremes. This does not create balance through intention, but through structure. The network itself makes sharing possible simply by existing. It is tempting to describe this as cooperation, but the fungus does not choose to help the forest. It grows in ways that allow it to survive, and the benefits to plants are a natural consequence. Over time, plants that can form these relationships thrive, while those that cannot often fail. The partnership becomes so common that entire ecosystems depend on it without ever acknowledging it. This dependence is rarely visible. forests appear to stand on their own, tall and independent. The quiet support beneath them goes unnoticed. The fungal body does not demand recognition for its role. It does not rise above ground to display its size or age. It remains where it has always been, woven into the soil, shaping the conditions that allow life above to continue. The idea that a single living being can exist at this scale challenges the way we think about separation. It suggests that individuality is not always contained within clear boundaries, that life can be spread out, interconnected and continuous rather than compact and defined. That something can be both one and many at the same time. This does not require imagination to accept. It is simply how fungi exist. The difficulty lies only in adjusting our perspective to match it. Beneath familiar ground, beneath paths and forests and fields, there may be organisms older than memory, larger than cities, moving slowly enough to feel still. They do not announce themselves. They do not demand space. They persist, shaping the world quietly, one thread at a time. In forests where these vast fungal bodies have had time to settle and spread, their presence begins to shape not just the soil, but the lives growing above it in subtle, far-reaching ways. The roots of trees do not sit alone in the ground, reaching blindly for water and minerals. They are almost always wrapped in fine fungal threads, so thin they are invisible to the naked eye, forming what scientists call mycorrhizal partnerships. These connections are not rare or unusual. They are the rule rather than the exception. Most plants on land rely on them, often without ever revealing the relationship on the surface. At the point where root and fungus meet, an exchange takes place. The tree produces sugars through photosynthesis, drawing energy from sunlight and air. The fungus cannot do this on its own. In return for those sugars, the fungal network delivers water and minerals absorbed from the soil, often from places far beyond the reach of the tree's roots. Phosphorus, nitrogen, trace, elements locked inside rock fragments, all become accessible through this partnership. Neither organism dominates the exchange. It is balanced by necessity. What makes this relationship remarkable is not just that it exists, but that it extends outward, linking many trees together through the same fungal body. A single network may connect dozens, sometimes hundreds of individual plants, forming a quiet web beneath the forest floor. Through this web, resources do not remain isolated. They move. Sugars produced by one tree may travel through fungal threads and appear in the roots of another. Water absorbed in damp soil may be shared with trees growing in drier ground nearby. This movement is slow and steady, not a rush or a surge. It happens continuously, without pause, guided by gradients of concentration and need, rather than conscious decision. Where one tree produces more sugar than it requires, some of that energy enters the shared network. Where another tree struggles, shaded by taller neighbours or damaged by insects, it may receive support indirectly through the same fungal threads. Older trees often play a central role in this process. Having had decades or centuries to establish themselves, they are deeply embedded in the underground network. Their roots are thick with fungal connections, and their access to sunlight allows them to produce large amounts of energy. Some of that energy moves outward through the fungal web, supporting younger trees that are still finding their place in the forest. Seedlings growing in deep shade may survive not because they compete successfully, but because they are quietly supported. This does not mean forests are free of competition. Trees still grow toward light. Roots still explore for space. But beneath that competition lies a layer of cooperation that changes how survival unfolds. Instead of each organism standing entirely alone, The network allows the forest to function more like a community, smoothing out extremes and increasing resilience. When drought arrives, trees connected to fungal networks often fare better than those without. The fungus increases the effective reach of the roots, accessing moisture held in tiny pockets of soil that roots alone cannot reach. When disease or pests affect one area, resources can be redirected, helping surrounding trees withstand the stress. The forest does not collapse as easily because its members are linked. This hidden connectivity helps explain why forests can feel so stable, even when individual trees fall or die. The loss of one organism does not immediately unravel the system. The nutrients contained in its body are reclaimed by fungi and redistributed. Space opens, light shifts, new growth emerges, supported by the same underground infrastructure that sustained what came before. In this way, death does not break the network, it feeds it. Fallen trees become long-term sources of nourishment, slowly absorbed and shared. What looks like decay from above is, below ground, a careful process of transformation. The forest does not waste what it loses, it reuses it. For a long time, this underground cooperation went unnoticed. Early models of forest ecology emphasized competition almost exclusively. Trees were seen as rivals, each struggling independently for light, water, and nutrients. The idea that they might be connected, that they might share resources through fungal intermediaries, challenged that view. It suggested that survival was not only about outcompeting neighbours, but also about being embedded in a system that could support the whole. As researchers studied these connections more closely, patterns began to emerge. Forests with intact fungal networks recovered more quickly from disturbance. Seedlings established more successfully near older trees. Nutrient cycles operated more efficiently. The underground web acted as a stabilizing force, not by preventing change, but by making change less destructive. This perspective alters how we think about strength in nature. Strength is not always found in isolation or dominance. Sometimes it lies in connection, in the ability to share, to redistribute, to support without awareness or intent. The fungal network does not choose which trees to help. It responds to gradients, to chemistry, to opportunity. And yet the outcome resembles care. The quiet nature of this system makes it easy to overlook. Nothing about a forest's appearance announces the presence of these connections. The trunks stand apart. The canopies compete for light. The soil looks still. Only through careful study does the hidden web reveal itself, extending between roots like an unseen lattice. Once you know it is there, however, it becomes difficult to imagine the forest without it. Each step across the ground feels less like walking on separate territories and more like moving across a shared foundation. The trees above are no longer isolated pillars, but members of a living system supported by something deeper and older. This shared foundation also allows forests to act as reservoirs of memory. Chemical signals produced in response to stress can travel through fungal networks, priming nearby plants to prepare their own defenses. A tree attacked by insects may trigger responses in its neighbours before the threat reaches them. Information moves quietly, encoded in molecules rather than messages, carried along threads that have no awareness of what they transmit. This movement of signals does not require speed to be effective. It only requires persistence. The network is always present, always available, ready to carry what the system produces. Over time, this constant availability becomes part of how forests endure. The longer you consider these hidden connections, the more the forest begins to feel less like a collection of individuals and more like a single distributed organism, Not one body with one mind, but a coordinated system where survival emerges from interaction rather than isolation. The fungal network does not dominate this system. It enables it, quietly, without drawing attention. Above ground, wind moves through leaves, light filters down in shifting patterns, animals pass through and leave again. Beneath it all, the connections remain, steady and patient, holding the forest together without ever asking to be seen. Within this underground web, something else is happening, something even quieter than the movement of nutrients and water. Along the same fine threads that bind roots together and carry minerals through the soil, faint signals travel. They are not sounds. They are not messages in the way we usually think of communication. They are tiny electrical changes, pulses moving slowly through the mycelium, rising and falling like a barely noticeable tide. For a long time, fungi were thought to be passive organisms, reacting only in simple ways to their environment. But when scientists began placing sensitive electrodes into fungal networks, they noticed patterns. Subtle shifts in electrical potential passed along the threads, spreading outward from one area to another. These pulses were not random. They appeared in response to changes in the environment, to damage, to the presence of nutrients, to shifts in moisture or temperature. The signals move slowly, far slower than nerve impulses in animals. There is no rush to deliver information. Instead, the rhythm resembles something more familiar and more gentle. The rise and fall of breath, the steady beat of a resting heart, patterns that repeat not to hurry something along, but to maintain balance over time. When a section of the mycelium encounters a rich food source, electrical activity increases locally. That change then propagates through nearby threads, altering growth patterns elsewhere in the network. Threads in other areas may slow their expansion or redirect themselves toward the new resource. When part of the network is damaged, similar pulses appear and growth adjusts accordingly, reinforcing some paths while abandoning others. This is not communication in the human sense. There are no symbols, no meanings attached to specific signals. Nothing is being said, and yet information is moving. The network is responding as a whole to events experienced locally. Each thread does not need to know what the entire system is doing. It only needs to react to changes in its immediate surroundings. The larger pattern emerges naturally from these countless small responses. Because of this, it can be misleading to describe fungal signaling as language. There is no vocabulary, no grammar, no intention to convey a message. What exists instead is sensitivity, the ability to register change and adjust behavior accordingly. Intelligence here is not centralized or verbal. It is distributed and embodied in growth itself. This way of responding feels slow and calm compared to the rapid signaling of animals. But speed is not the measure of effectiveness. The fungal network does not need to react instantly to survive. It operates in an environment where changes unfold gradually. Its responses are tuned to that pace, allowing it to conserve energy and remain stable over long periods. These electrical rhythms are not constant. They shift with conditions. During periods of abundance, signaling may become more frequent as growth accelerates and the network reorganizes itself. During drought or cold, activity slows, settling into a quieter baseline as the organism conserves resources. The pulses reflect the state of the system, not as a report, but as a living process. What makes this especially striking is that these signals occur without any nervous system. There are no specialized cells dedicated to communication, no brain coordinating responses. The same threads that absorb nutrients and anchor the organism in place also conduct these faint electrical changes. Structure and function are inseparable. The body itself is the medium. In this sense, the fungal network behaves less like an animal and more like a landscape that responds to weather. When rain falls, rivers swell. When drought comes, they recede. No decision is made, yet the system adapts. The fungal network responds in a similar way, its electrical activity reflecting the conditions it experiences rather than directing them. This kind of intelligence challenges familiar definitions. We often associate intelligence with speed, complexity, and visible behavior. But fungi demonstrate that responsiveness does not need to be loud or fast to be effective. Their awareness, if it can be called that, is woven into their structure. It exists as sensitivity rather than thought. For the forest above, this quiet signaling has consequences. Because fungal networks link multiple plants together, changes experienced by one can ripple outward. A tree under stress may alter the chemical environment of its roots. The fungal threads connected to those roots respond electrically, and growth patterns adjust elsewhere. Neighbouring plants may receive resources differently. The system shifts without any part of it knowing the whole story. This distributed responsiveness allows forests to function as integrated systems rather than collections of isolated individuals. It also means that resilience emerges naturally. When conditions change, no single point of failure determines the outcome. Adjustments happen everywhere, in small ways, across the network. There is something reassuring about this kind of intelligence. It does not require constant monitoring or control. It does not depend on awareness of the future. It simply responds to what is happening now in the moment and allows those responses to accumulate over time. In a world that often values quick answers and immediate action, fungal signaling offers a different model. One where listening happens at the level of structure rather than attention. Where response is gradual rather than urgent. Where stability is maintained not by force, but by continual adjustment. The pulses moving through mycelium are too faint to notice without instruments. They do not announce themselves. They do not disrupt the quiet of the forest. And yet, they are always there, rising and falling as conditions shift, maintaining a subtle internal rhythm beneath the ground. This rhythm does not demand interpretation. It does not need to be translated into words. It exists simply as part of the organism's way of being in the world, a way of staying connected to itself and to its environment without needing sound, symbols, or speed. Above ground, leaves move in the wind. Birds call and then fall silent again. The surface world is filled with signals that come and go quickly. Below, the fungal network continues its slower conversation, one that does not interrupt or intrude, but sustains the system quietly over time. It is a reminder that intelligence does not always announce itself, that awareness does not require language, that responsiveness can be gentle and still be profound. The forest does not need to hear these signals for them to matter. The work they do is already unfolding, steady and unobtrusive, woven into the fabric of the soil itself. In certain forests, when daylight fades and the last movement of animals settles into stillness, something unexpected remains. It does not flicker or flare. It does not compete with the stars or break the darkness apart. It appears quietly, close to the ground, as a soft presence rather than a display. From decaying logs, from damp soil, from the bases of trees, faint points of light begin to show. Mushrooms glowing gently in shades of green or blue, steady and calm, as if the forest itself has chosen to leave a few lamps on through the night. This glow is not a reflection, and not a trick of the eyes. It is light produced by the mushrooms themselves, a phenomenon known as bioluminescence. Unlike fire, it gives off no heat. Unlike artificial light, it does not overwhelm the surrounding darkness. It simply exists, constant and unhurried, illuminating only what lies closest to it. The effect is subtle. You could walk past it without noticing if you were not paying attention, and yet, once seen, it is difficult to forget. Bioluminescent fungi have been observed in forests across the world, from temperate woodlands to tropical rainforests. More than 70 species are known to glow, though many are rarely seen. Some emit light only from their caps, others from their stems, and some from the mycelium itself, glowing softly along fallen wood like a quiet outline of where decay is taking place. The light can last for hours, sometimes days, sustained by chemical reactions occurring steadily within the cells. The chemistry behind the glow is precise and ancient. It involves molecules that react with oxygen, releasing energy in the form of light. The process is efficient, producing very little wasted heat. It is the same general principle that allows fireflies to glow, though the exact chemicals differ. In mushrooms, the glow is continuous rather than pulsed, creating an even, unbroken illumination that feels almost meditative. No one knows exactly why these mushrooms glow, though several ideas have been suggested. One possibility is that the light attracts insects during the night, drawing them toward the mushroom so they can carry spores away on their bodies. Another idea is that the glow may serve as a byproduct of metabolic processes, a side effect of chemistry rather than a targeted function. It may also play a role in deterring animals that might otherwise feed on the fungus. The truth may involve a combination of these factors, varying from species to species. What matters less than the reason is the effect. To encounter bioluminescent mushrooms in the wild is not startling in the way sudden light can be. It is soothing. The glow feels like part of the darkness rather than an interruption of it. The forest remains quiet, shadows remain deep. The light simply adds a layer of gentleness, revealing textures and shapes that would otherwise remain hidden. Unlike torches or lanterns, these mushrooms do not demand attention. They illuminate only what is nearby, allowing the rest of the forest to remain untouched by their presence. Fallen leaves glow faintly at the edges. Bark takes on a soft sheen. The ground seems closer, more intimate, as though the forest is breathing slowly and evenly in the dark. This quality has inspired stories for centuries. Long before the chemistry was understood, people spoke of foxfire, fairy lights, or spirits moving through the woods. These stories did not frame the glow as dangerous or dramatic. More often, they described it as guiding, comforting, or quietly mysterious. Even now, knowing the science does not entirely strip away that feeling. Understanding how the light is produced does not lessen its calm. There is something grounding about light that does not rush or change. In a world filled with flashing screens and constant motion, a steady glow feels almost unfamiliar. The mushrooms do not blink. They do not pulse in patterns meant to attract attention. They simply shine, patiently, as long as the chemical reaction continues. The glow is often brightest in complete darkness. In daylight it disappears entirely, hidden by the overwhelming presence of the sun. This means the mushrooms reveal themselves only when the forest is otherwise quiet. They belong to the night not as spectacle, but as accompaniment. Their light does not compete with moonlight or starlight. It fills the spaces in between. Some bioluminescent mushrooms grow in clusters, creating small constellations on the forest floor. Others appear singly, a lone point of light marking a log or stump. In either case, the effect is the same. The forest feels less empty, not louder or busier, just gently inhabited. These mushrooms are not common. Many people live their entire lives without seeing one outside of photographs, and yet they have likely always been there, glowing quietly in places rarely visited after dark. Their rarity adds to their calm rather than diminishing it. They do not flood the forest with light. They offer just enough to remind you that even in darkness, life continues its quiet work. The glow also reflects the broader character of fungi themselves. It is functional, efficient, and understated. It does not waste energy. It does not persist when conditions are not right. It is simply another way the organism interacts with its environment, another expression of a system tuned to balance rather than excess. In laboratories, scientists can measure the intensity of this light, analyze its wavelength, and track the reactions that produce it. But those measurements capture only part of the experience. In the forest, the glow feels less like data and more like atmosphere. It changes how space feels, how distance is perceived, how close the ground seems. There is no urgency in this light, no sense that it must be noticed quickly before it vanishes. It is there as long as the chemistry allows, and then it fades without drama. No signal announces its end. Darkness simply returns to where it was before. This quiet appearance and disappearance mirrors the larger rhythm of fungal life. Mushrooms rise when conditions are right. They release spores, they collapse. Mycelium continues. Light appears. Light fades. Nothing is forced. Nothing is prolonged beyond its usefulness. To know that such light exists beneath the canopy, appearing only when the forest is at rest, adds another layer to the idea of life happening out of sight. It suggests that even when we cannot see or hear activity, systems are still functioning, still expressing themselves in subtle ways. The glow of mushrooms does not seek to transform the forest. It does not reshape the night. It coexists with it, adding a gentle presence that feels more like reassurance than wonder. A reminder that darkness is not absence, and that quiet does not mean empty. Every forest is built on endings. Leaves fall, branches snap under the weight of snow, trees age, weaken, and eventually stop standing. From the surface, this can look like loss, like something disappearing, but beneath that appearance, another process begins almost immediately, one so steady and reliable that forests have depended on it for hundreds of millions of years. The fallen leaf does not remain a leaf. The fallen tree does not remain wood. They become something else, slowly and completely, guided by organisms that specialize not in growth upward, but in transformation inward. Fungi are at the center of this work. When a leaf settles onto the forest floor, it carries with it the carbon it pulled from the air, the minerals it absorbed from the soil, the energy it stored during its life. On its own, that leaf would persist for years, even decades, resisting breakdown. Lignin, one of the main components of wood and leaves, is especially difficult to decompose. Few organisms can touch it. Fungi can. They release enzymes into their surroundings, dissolving complex molecules into simpler forms that can be absorbed and reused. This process does not happen quickly. There is no sudden collapse. Instead, the leaf softens. Its structure loosens. Fungal threads move through it, almost imperceptibly, breaking bonds that once held it rigid. What looks like decay is actually careful disassembly. Each molecule is taken apart and repurposed. Carbon returns to the soil and eventually to the air. Nitrogen becomes available again to plants. Trace minerals re-enter circulation. The forest floor darkens and thickens, enriched by what has passed through it. Fallen trees follow the same path, but on a longer time scale. A trunk that once supported a canopy may lie on the ground for decades. During that time, fungi move in quietly. Some specialize in breaking down cellulose, others in dismantling lignin. Together they turn solid wood into soft matter, then into soil, mosses, and seedlings take root along the way, drawing nourishment from the gradual transformation. The tree does not vanish, it changes state, feeding countless other lives as it does. Without fungi, this process would stall. Forests would fill with debris, nutrients would remain locked inside dead material, unavailable to new growth. Soil would thin and lose fertility. Life above ground would struggle, not because of lack of energy, but because of lack of recycling. Fungi prevent this not through force or speed, but through persistence. They work slowly enough to keep ecosystems balanced, ensuring that release matches demand. This slow pace is essential. If everything broke down at once, nutrients would flood the system, overwhelming plants and microbes alike. If breakdown were too slow, growth would stall. Fungi maintain a middle path, one shaped by deep evolutionary tuning. Nothing is rushed, nothing is left untouched forever. This balance offers a quiet reassurance. In the fungal view of the world, nothing is ever truly wasted. What ends becomes material for what follows. Even death is not an interruption, but a transition. The energy stored in living tissue does not disappear. It moves, guided by processes that have no need to hurry. This perspective softens the idea of loss. A fallen leaf is not gone. It is becoming soil. A dead tree is not finished. It is feeding the forest that will replace it. These transformations happen whether or not they are observed. They do not depend on recognition. They simply unfold season after season, maintaining the conditions that allow life to continue. In some ecosystems, fungi are so effective at recycling that very little organic matter accumulates. In others, where conditions are colder or drier, decomposition slows and thick layers of organic soil build up over centuries. Even there, fungi continue their work at a reduced pace, waiting patiently for warmth or moisture to return. They do not abandon their role when conditions are difficult. They adjust. This patience is one of their defining traits. Fungi do not require constant activity to remain alive. They can slow their metabolism, reduce growth, and persist in a state of readiness for long periods. When conditions improve, they resume their work without needing to start over. This ability to pause without ending allows cycles to continue even through harsh periods. It is one reason ecosystems recover after disruption. Fires, storms, and floods may clear the surface, but beneath it, fungal networks often survive, ready to break down what remains and support new growth. The forest does not need to be rebuilt from scratch. The foundation is already there. This continuity is rarely visible. Walking through a forest, it is easy to focus on what is standing, what is green, what is alive in obvious ways. The work happening underfoot goes unnoticed, and yet it is this unseen labour that makes visible life possible. Fungi do not compete with plants and animals for attention. They support them by handling what others cannot. They occupy a role that is both humble and essential, turning complexity back into simplicity, over and over again. There is something deeply calming about this role. It suggests that systems can be stable without being static, that change does not have to be violent or abrupt. In the fungal world, change is gradual and continuous. One form dissolves into another, one cycle feeds the next. The forest breathes not just through leaves, but through soil. Over time, this process shapes entire landscapes. The thickness of forest soil, the fertility of fields, The structure of ecosystems all depend on fungal recycling. Even human agriculture relies on it, often unknowingly. Crops grow better in soils where fungal communities are intact. Degraded soils struggle because the recycling network has been disrupted. Restoring it takes time, patience, and conditions that allow fungi to return. This dependence extends beyond forests. Grasslands, wetlands, even deserts host fungal species adapted to their environments, each performing the same fundamental task in different ways. Wherever organic matter accumulates, fungi are there, quietly dismantling and redistributing it. They do not discriminate between what is natural and what is human-made. Given time, they work on everything. Wood, leaves, paper, fabric, even some plastics and pollutants can be broken down by specialized species. This ability to transform rather than discard has made fungi objects of renewed interest in recent years. Scientists study them for their potential to clean contaminated soils, to recycle waste, to restore damaged environments. But long before humans thought to apply fungal processes intentionally, fungi were already performing these services for the planet as a whole. They do not require instruction. They do not need oversight. They simply do what they have always done. Seen this way, the forest floor becomes a place of quiet, reassurance rather than decay. What looks like accumulation is actually movement slowed down. What looks like loss is part of a longer exchange. Nothing lingers forever, but nothing disappears without contributing to what comes next. This cycle does not need to be understood to function. It does not need to be acknowledged. It continues beneath our awareness, steady and reliable, turning endings into beginnings with a patience that asks for nothing in return. It can be useful sometimes to imagine the world by removing something essential, not to create fear, but to better understand the quiet work being done every day. If fungi were suddenly absent, not fading gradually but simply gone, the change would not arrive all at once. There would be no immediate collapse. Trees would still stand, leaves would still fall, animals would still move through forests and fields. For a short while, the surface of the world might look almost the same. The difference would begin beneath our notice. Fallen leaves would remain where they landed, branches would not soften, dead wood would resist breakdown, holding its shape year after year. The forest floor would slowly thicken, not with life, but with accumulation. Without fungi to release enzymes and dismantle complex structures, organic matter would pile up. Nutrients would remain locked away, unavailable to new growth. Soil would begin to lose its richness, not because life had vanished, but because it could no longer be recycled. Plants would struggle first in subtle ways. Growth would slow, seedlings would fail more often. Trees would show signs of nutrient deficiency, even while standing among what appeared to be plenty. The problem would not be absence, but inaccessibility. The materials needed for life would still be there, just out of reach. Over time, this imbalance would deepen. Forests would become choked with their own remains. Grasslands would lose fertility. Wetlands would fill with undecomposed plant matter, altering water flow and chemistry. The planet would not suffocate quickly, but it would steadily lose its ability to renew itself. The cycles that once flowed smoothly would stall. This thought experiment is not meant to alarm. It is meant to highlight how quietly fungi maintain balance. They do not prevent death. They make death usable. They ensure that endings do not accumulate into obstruction. Without them, the world would not explode into chaos. It would simply slow, harden, and become less flexible over time. What is striking is how quickly balance would return if fungi were allowed back in. Introduce them again, and decomposition resumes. Leaves soften, wood yields, nutrients begin moving once more. Soil rebuilds itself gradually, layer by layer. Life does not need to be instructed to recover. It only needs the processes that allow change to keep moving. This capacity for restoration is one of the most reassuring aspects of fungal life. Fungi do not create stability by freezing systems in place. They create it by allowing constant transformation. Nothing becomes stuck permanently. Nothing accumulates beyond usefulness. Even disruption becomes material for renewal. This is why ecosystems with intact fungal communities recover more easily from disturbance. Fires clear vegetation, but fungi recycle what remains. Storms topple trees, but fungi turn them into soil. Human impact damages landscapes, but given time and conditions, fungi begin the slow work of repair. They do not erase damage quickly. They soften it, integrate it, and redistribute its materials until the system can function again. In this way, fungi act less like guardians standing watch and more like caretakers moving quietly through a space, tidying without being seen. They do not stop change from happening. They ensure that change does not become permanent damage. This role is so deeply embedded in Earth systems that it often goes unnoticed. We tend to focus on what grows, what moves, what is visible. But growth depends on recycling, and movement depends on stability. Fungi provide both without ever demanding attention. They do not need to be admired to function. They do not need to be understood. Their presence is enough. Thinking about what would happen without them makes their quiet success clearer. It reveals how much of the planet's balance depends on processes that operate slowly and invisibly. It suggests that resilience is not built through strength alone, but through systems that allow constant adjustment. This idea extends beyond forests and fields. Even in places where life appears sparse, fungi are present, performing the same essential work in different forms. In deserts, they break down scarce organic matter and stabilize soil. In tundra, they operate at low temperatures, slowly recycling what little growth occurs. In oceans, fungal relatives help process organic debris sinking from the surface. Everywhere, the pattern repeats. Breakdown followed by reuse, ending followed by continuation. This continuity offers a quiet sense of security. It means that the planet does not rely on perfection to persist. Systems can be disrupted, altered, even damaged, and still recover because the underlying processes remain. Fungi do not prevent mistakes or accidents. They make it possible to move beyond them. In a world that often feels fragile, this hidden durability is easy to overlook, but it is there, built into the soil, carried through networks beneath our feet, waiting patiently whenever conditions allow it to work. The thought of a world without fungi is unsettling, not because it would end quickly, but because it would lose its ability to adapt. The return of fungi restores that adaptability, reminding us that balance is not a static state, but a continuous process, and that process does not require urgency or control. It requires time, patience, and the quiet labor of organisms content to remain unseen. People often describe mushrooms as sudden, as if they arrive without warning, as if they belong to the category of things that happen quickly while we are not looking. You walk a familiar path one afternoon, and the ground is bare, scattered only with leaves and twigs, and then after a night of rain, the same place appears transformed, dotted with caps and stems as though the earth decided to decorate itself while everyone slept. It is easy to believe that mushrooms grow fast because they want to, or because rain somehow creates them on the spot, but the truth is much slower and much quieter. The rain does not make the mushroom exist. It only gives permission for something that has already been waiting a very long time. Beneath the soil, sometimes just centimeters below the surface, sometimes deeper, mycelium has been growing patiently for months or years. It spreads not in a hurry but with persistence, navigating around stones, roots and grains of sand, expanding whenever nutrients allow, resting when conditions are poor. This network stores energy the way a tree stores it in wood, accumulating resources gradually, never wasting them on display. The mushroom we notice is not the beginning of the process. It is the result of preparation so extensive that it becomes invisible to casual timekeeping. Rain changes the balance of moisture in the soil, softening resistance and signaling that the moment is right. Temperature shifts help too, especially the cooling nights of autumn or the gentle warmth of spring. When these conditions align, the mycelium responds, not by thinking or deciding, but by following chemical and physical cues it has evolved to recognize. Water pressure increases within its cells. Growth accelerates, not chaotically, but along structures that were already mapped out. What feels sudden to us is simply growth happening at a scale we're not used to observing. In a time-lapse video, a mushroom's emergence looks dramatic, the cap pushing upward, unfolding, stretching toward open air. In real time, it feels like a quiet surprise, but the speed belongs only to the final step. The waiting came first. Some mycelial networks that produce mushrooms after rain may be several years old, quietly feeding on fallen leaves, dead roots, or buried wood long before any fruiting body appears. In forests, a fallen tree might lie for a decade while fungi colonize it slowly, digesting its structure from the inside. Only when the internal network is well established do mushrooms appear, sometimes long after the original tree has blended back into the forest floor. This creates a mismatch between cause and effect that can be misleading. We see rain, and then mushrooms, so we link the two directly. But rain is more like a key than a creator. It unlocks a door that was already built. This pattern repeats across ecosystems. In grasslands, mushrooms wait beneath turf, responding to seasonal moisture. In deserts, some species lie dormant for years, surviving as resilient structures until rare rainfall allows a brief flowering of fungal life. In these places, mushrooms may appear even more miraculous because the waiting is longer and the conditions rarer, but the principle remains the same. Emergence is never rushed. It is simply revealed. This long preparation changes how we can think about patience. Mushrooms do not wait passively. They work quietly. Even during periods when nothing seems to be happening above ground, they are active below, adjusting, growing, and reorganizing. The waiting is full, not empty. It is a time of accumulation rather than delay. This is one of the reasons mushrooms have inspired so much folklore. To earlier cultures, something that appeared overnight felt magical, even supernatural. Fairy rings, sudden flushes of mushrooms after storms, and the way some species seem to rise directly from decay all contributed to the sense that mushrooms existed on a different schedule than plants. In a way they do. Their visible life is brief, sometimes lasting only days, but their invisible life is long and continuous. Understanding this helps soften the idea of suddenness. Many things in nature follow this pattern. Forests regenerate slowly and then bloom quickly. Seeds lie dormant until the right conditions arrive. Animals prepare quietly for migration before moving all at once. Mushrooms simply make this rhythm visible in a striking way. They remind us that emergence does not mean instant creation. It means readiness, meeting opportunity. The lesson is not dramatic, it is gentle. It suggests that much of what appears to happen quickly has been forming patiently for a long time. This can be comforting when applied beyond the forest floor. Growth does not always announce itself as it happens. Progress does not always look like movement. Sometimes it looks like stillness, like waiting, like nothing at all. And then, when conditions align, the result becomes visible almost all at once. Mushrooms embody this idea without intention or metaphor. They simply live it. Their patience is built into their biology. They do not rush because there is no advantage in rushing. They wait because waiting allows them to succeed. The soil becomes a record of this patience. Layered within it are networks of fungi at different stages of readiness, some preparing to fruit soon, others content to remain unseen for years. When rain falls, it does not summon them all. It only activates those that are ready. Others continue waiting, unaffected, storing energy for a future moment. This creates waves of emergence that feel spontaneous, but are actually staggered outcomes of long processes overlapping in time. Once you notice this, the forest after rain feels different. Instead of seeing sudden abundance, you begin to sense the hidden continuity beneath it. Each mushroom becomes a marker of time already spent, not time just begun. The ground feels less like a stage for surprise and more like a library of ongoing work, most of it unreadable unless you know how to look. And even then, much of it remains beyond observation. That is part of the calm these organisms offer. They do not demand to be watched. They do not require recognition. They proceed according to conditions, not expectations. When the moment arrives, they appear. When it passes, they fade, leaving the real organism still quietly at work below. This rhythm repeats endlessly, season after season, year after year, without urgency or hesitation. It suggests a different relationship with time, one where patience is not a pause but a process, and emergence is not a beginning but a brief glimpse into something much larger and much older that has been there all along. Sometimes the ground itself seems to draw shapes, careful and calm, as if an invisible hand traced lines through grass and soil while no one was watching. In open meadows or quiet lawns, mushrooms occasionally appear arranged in near-perfect circles, arcs so smooth they feel deliberate. These formations have been noticed for as long as people have walked fields, and long before there were microscopes or soil science, they invited stories. In European folklore, these rings were said to mark places where fairies danced at night, or where spirits gathered, or where the earth itself had been touched by something not entirely human. The idea was not meant to frighten, but to explain a pattern that seemed too precise to be accidental. A circle implies intention. It suggests planning. Yet the calm truth behind these shapes is even more soothing than the stories that grew around them. A fairy ring begins with a single point, a spore that germinates in soil and sends out mycelial threads in all directions. The growth is even, not because the fungus is measuring, but because conditions around that starting point are similar in every direction. The mycelium expands outward slowly, digesting organic matter as it goes, using what it finds, and then moving on. At the centre, nutrients become depleted over time, and growth slows or stops. At the edges, where fresh material is still available, the fungus continues outward. When conditions are right for fruiting, mushrooms appear along this active edge. From above, this line of activity forms a circle, sometimes nearly perfect, sometimes broken by obstacles like rocks, paths, or changes in soil. The geometry is not planned. It emerges naturally from equal expansion over time. What makes these rings especially striking is that they grow. Each year, the circle becomes slightly larger as the mycelium continues its outward journey. Some fairy rings are only a few meters across, while others can span dozens of meters, their origins lost to memory. In some cases, scientists have estimated rings to be hundreds of years old, expanding slowly at a rate of just a few centimeters per year. The mushrooms that appear are temporary, but the pattern persists. Year after year, the ring reasserts itself, a quiet record of time passing beneath the surface. Unlike human-made circles, which are drawn quickly and fixed in place, fungal circles are dynamic. They move, they breathe outward. They respond to seasons and weather, sometimes appearing boldly, sometimes barely at all. The grass inside a fairy ring often looks different too. In some rings, the grass is darker and more lush along the arc where mushrooms appear. This is because the fungus releases nitrogen into the soil as it breaks down organic matter, enriching the ground at its active edge. In other cases, the grass inside the ring may be thinner or paler, reflecting areas where nutrients have already been consumed. These subtle changes make the circle visible even when mushrooms are not present, like a faint echo of underground activity written onto the surface. To notice this is to see the soil not as static ground, but as a living canvas shaped by slow processes. What is comforting about fairy rings is how little effort they require. There is no urgency in their formation, no sudden movement, just consistent expansion guided by availability and balance. The fungus does not hurry to complete the circle. It has no concept of completion at all. The shape is simply a snapshot of growth frozen for a moment in time. If left undisturbed, the ring will continue to expand long after any individual mushroom has decayed, its geometry stretching gently across years and decades. This natural order can feel reassuring. It shows how structure can arise without control, how patterns can form without instruction. The circle is not imposed on the landscape, it grows out of it. This kind of order is different from symmetry designed by human hands. It is flexible, responsive, and tolerant of imperfection. If a patch of soil is too dry, the ring may break there. If a tree root blocks the way, the circle bends. The overall pattern remains, but it adapts, accommodating reality rather than resisting it. When people once attributed fairy rings to dancing spirits, they were responding to this sense of quiet mystery. The explanation we have now does not remove the wonder, it simply shifts it. Knowing that these circles are the visible edge of a living network does not make them less magical. It makes them more grounded, more connected to the rhythms that shape everything else. They become reminders that beauty does not always require intention. Sometimes it emerges as a side effect of patience. Fairy rings also challenge how we think about beginnings and endings. There is no clear start visible once the ring is large. The center tells the story of what has already passed, while the edge shows what is happening now. The future lies just beyond the current arc, in soil that has not yet been reached. This layered timeline exists all at once, quietly, beneath grass that might otherwise seem ordinary. Standing inside a fairy ring can feel like standing in the middle of a slow-moving clock, one that measures time not in seconds, but in seasons and nutrient cycles. In this way, fairy rings connect naturally to the patience already seen in mushrooms that wait years to appear, and networks that span entire forests. They are another expression of the same principle. Growth radiates outward, change leaves traces, order emerges without announcement. The circles are not messages meant for us, but they are invitations to look more closely, to notice how much of the world organizes itself without force or urgency. They suggest that calm systems can still be powerful, that consistency over time can produce shapes as elegant as anything planned. Once you've seen a fairy ring with this in mind, it is difficult to forget. Even when the mushrooms are gone, the memory of the pattern lingers. The field feels subtly different, as though something continues beneath it, patient and precise, and it does. The mycelium keeps moving outward, indifferent to whether it is observed. The circle grows, the grass responds, time passes, the shape remains, expanding quietly, reminding anyone who notices that order does not always arrive with explanation or spectacle. Sometimes it simply grows, one invisible thread at a time. The circles left behind in grass and soil are only part of the story, because while mushrooms often seem rooted to one place, much of their existence is carried far beyond where they grow. Even now, as you sit or lie still, the air around you is not empty. It is alive with motion too small to notice, filled with drifting particles that belong to forests, fields, parks, and places far beyond your view. Mushroom spores move constantly through this shared space, light enough to float on the slightest current, patient enough to travel without direction, present whether we are aware of them or not. They do not rush, they do not swarm, they simply exist as part of the atmosphere, as common and unnoticed as dust, yet far more alive. Every mushroom releases spores not as a dramatic event, but as a quiet continuation of its life. Some release them in steady streams, others in soft puffs, others so gently that the dispersal is invisible even at close range. Once free, the spores become travelers. They drift upward with warm air, sideways with breezes, downward with gravity, and outward with storms. A single breath of outdoor air can contain thousands of them, each one carrying the potential to become part of a new network if it happens to land somewhere suitable. Most will not. They will settle onto stone, water, pavement, or dry ground, and remain dormant or perish quietly. That is not failure. It is simply abundance at work. Fungi do not depend on precision. They depend on presence. This constant release means that the boundary between where mushrooms are and where they are not is much thinner than it seems. You do not have to be in a forest to be connected to one. The air itself does that work for you. Spores from distant woodlands mix with those from local soil, riding the same invisible currents that move pollen, moisture, and scent. In this way, ecosystems that appear separate are gently blended together above our heads. The atmosphere becomes a shared layer, common meeting place where particles from different landscapes mingle without conflict. Breathing is part of this exchange. With every inhale, you draw in air that has passed over leaves, soil, water, and living surfaces. Some of that air has moved through forests earlier in the day. Some of it has risen from the ground where fungi were releasing spores hours or even minutes before. You're not absorbing the forest in any dramatic way, but you're connected to it physically, moment by moment, through the simple act of breathing. This connection is quiet and constant. It does not require effort or awareness. It does not change how you feel in any sudden way. It simply exists as part of being on this planet. There is something calming in that idea. It suggests that separation is less complete than we imagine. Even indoors, even in cities, spores find their way inside. They settle on windowsills, drift through open doors, circulate through ventilation systems. Urban air carries its own fungal signature, shaped by parks, gardens, decaying wood, and the remnants of plant life woven into built environments. The fungal world does not stop at the edge of the wild. It adapts, disperses, and persists wherever conditions allow. This is not invasive or threatening, it is simply continuity. Fungi have evolved to rely on the atmosphere because the atmosphere belongs to everyone. It moves freely across borders and boundaries, ignoring ownership and intention. In doing so, it links distant places in subtle ways. A spore released in one forest may travel miles before settling. Another may rise into clouds, hitching a ride with water vapour and falling later as rain somewhere else entirely. Scientists have found fungal spores at high altitudes, even miles above the surface, mixed among dust and ice crystals. Some act as nuclei around which raindrops form, meaning fungi may even play a role in shaping weather patterns. This is not something we feel directly, but it is another example of how deeply integrated they are into planetary systems. The air you breathe is not just oxygen and nitrogen. It is a living archive of movement and exchange. Knowing this does not require alarm or fascination. It can simply be acknowledged as a background truth. Just as soil is never truly inert, air is never truly empty. It carries traces of countless organisms moving through time and space together. Fungal spores are part of that gentle traffic. They do not announce themselves. They do not ask permission. They simply flow. This shared atmosphere creates a sense of intimacy with the planet that is easy to overlook. You're not separate from distant forests or unseen meadows. You're already participating in their cycles in the smallest possible way. The same air that brushes mushroom caps and lifts spores from gills also moves through your lungs and across your skin. This is not meant to feel overwhelming. It is meant to feel grounding. The planet does not require constant attention to remain connected. It does that work automatically. Fungi trust the air to do its job, just as trees trust wind to move pollen and seeds. There is no urgency in this system. Spores can wait. Some remain dormant for years before encountering the moisture and nutrients they need. Others never germinate at all. That does not diminish the system's success. It reflects its patience. Abundance allows for gentleness. Presence replaces precision. In this way, fungi mirror the rhythms already seen in their underground networks and slow growth patterns. They do not force outcomes. They allow conditions to decide. The idea that spores surround us constantly does not have to be unsettling. It can be comforting to know that life is always nearby, even when it is quiet and invisible. The air carries reminders that the planet is active even when we are resting. It does not pause when we do. It continues its exchanges calmly, steadily, without expectation. Breathing becomes not just a biological necessity, but a small participation in a much larger circulation. You inhale, the air moves, spores drift. Somewhere else, rain falls, soil softens, threads grow. None of this requires attention to be meaningful. It simply happens, linking places as moments together through motion too slow and too small to demand notice. This constant presence makes the world feel less fragmented. Forests are not isolated pockets of life. They extend outward through air, through spores, through shared atmosphere. You're never entirely outside of them. Even in stillness, even in sleep, the connection remains. The planet continues to breathe with you, quietly, evenly, carrying its hidden travelers along without effort or sound. Air does not stay in one place for long. It warms, rises, cools, sinks, and drifts sideways in vast, slow rivers that circle the planet without borders or destinations. Within these moving layers, mushroom spores continue their quiet journeys, travelling far beyond the forests or fields where they were released. They do not know where they're going. They do not need to. Lifted by convection currents, carried by storms, nudged along by prevailing winds, spores can cross valleys, seas, and entire continents without ever touching the ground. Some remain airborne for days or weeks, suspended in the atmosphere like dust motes in sunlight, only on a scale far larger and far slower. This is how fungi extend themselves across the planet, not by force or speed, but by trusting motion itself. When spores rise high enough, they enter layers of air that move great distances. Winds at altitude can carry them thousands of kilometers before gravity, moisture, or chance brings them back down. Scientists have detected fungal spores drifting far from any visible source, collected from ships in the middle of oceans or measured high above cities and wilderness alike. These spores do not travel alone. They mingle with pollen grains, salt particles lifted from waves, fragments of soil, and droplets of water. The sky becomes a shared passage, a place where pieces of many ecosystems overlap briefly before continuing on. When rain begins to fall, some of these travelers return to the surface. Raindrops form around tiny particles, sometimes including spores, pulling them downward gently. A forest may receive rain that carries spores from far beyond its borders. A meadow may host fungi whose ancestors drifted in from distant mountains. This is not an invasion, it is a quiet blending. Over long periods, this movement helps maintain genetic diversity among fungal populations, preventing isolation and allowing adaptation to changing conditions. The planet, through its atmosphere, encourages connection without coordination. From a human perspective, this scale of travel can be difficult to imagine. We tend to think in terms of routes, maps, and destinations. Spores ignore all of that. They do not follow paths. They respond only to physics. Warm air lifts them, cold air drops them, moisture gathers them, dryness releases them. In this way, they participate in the same systems that move clouds, shape weather, and distribute heat around the globe. The fungal kingdom does not sit beneath these systems, it is woven into them. This creates a planetary network that is both vast and gentle. No single spore is important. No individual journey is necessary to track. The success lies in the collective, in the steady background movement that never stops. Over thousands of years, this slow dispersal allows fungi to colonize new regions as climates shift. As ice retreats or advances, as deserts expand or shrink, spores arrive quietly, testing conditions, waiting for opportunity. Some succeed, many do not. The system does not rush. It does not mind repetition. It simply continues. This perspective can feel calming because it removes urgency from change. The planet does not rely on perfect timing. It relies on constant motion and patience. Fungi embody this approach. They do not attempt to control where they end up. They allow the world to carry them where it will. This trust in systems larger than any single organism is one reason fungi have persisted for so long. They do not resist the planet's movements, they use them. Thinking of Earth as a connected system rather than a collection of separate places can soften how we imagine distance. A forest on one continent is not entirely separate from a forest on another. They share air, they share spores. Over long spans of time, they share genetic material and ecological patterns. Mountains influence rain far away. Oceans shape winds that feed inland ecosystems. Fungi move within these flows, adjusting quietly, spreading without claiming territory. The idea of travelers without maps is not romantic. It is accurate. Spores do not navigate. They are navigated. And yet, over time, this passive movement results in remarkable resilience. Fungi are among the first organisms to arrive in newly formed environments, from volcanic islands to retreating glaciers. Their spores reach these places before plants, before animals, before soil fully develops. They begin the slow work of breaking down rock, trapping organic matter, and preparing ground for other life. This is not because they aim to be pioneers, it is because their dispersal system makes arrival inevitable. Given enough time, spores reach everywhere that air reaches, and air reaches almost everywhere. This global movement creates a sense of continuity that is easy to miss. The planet is not stitched together by roads or borders, but by currents. Life participates in these currents whether it intends to or not. Fungi have adapted to this reality so thoroughly that it defines their existence. They release spores not knowing where they will land, confident that somewhere, sometime, conditions will align. This confidence is not emotional, it is evolutionary. It has worked for hundreds of millions of years. There is something soothing in recognizing that so much of life proceeds without direction or control, and yet still succeeds. The planet does not require constant management to remain connected. Its systems do the work automatically. Wind moves, rain falls, spores travel, networks grow, forests change. The movement never stops, but it also never hurries. Everything unfolds within rhythms large enough to absorb variation and error. From this perspective, distance becomes less meaningful. What matters is flow, and fungi are masters of flowing with the world rather than pushing against it. Their spores remind us that connection does not require intention, it only requires openness to movement. As air continues its endless circulation around the globe, it carries with it tiny signs of life from countless places, blending landscapes together quietly. The planet breathes, and in that breath, fungi travel, linking soil to sky, forest to field, continent to continent, without sound, without maps, and without pause. Movement through air eventually meets resistance in the form of ground, and when spores settle, they encounter environments that are not always gentle. Some land where fire has recently passed, where the surface is blackened and the familiar signs of life appear absent. Others fall into places where winter holds the soil frozen for months at a time. To human eyes, these conditions look hostile, even final. Yet fungi have learned to meet extremes without conflict. They do not fight fire or cold. They persist alongside them, adjusting quietly, waiting, enduring. After a forest fire, the land can feel emptied, stripped of colour and sound, reduced to ash and silence. But beneath that surface, fungal networks often remain alive. Many species are protected underground, insulated by soil and moisture, their threads intact even as flames move overhead. Some fungi go further than survival. They are adapted to fire itself. In the weeks and months following a burn, certain mushrooms appear in abundance, rising from ground that still smells faintly of smoke. Morels are one well-known example, their honeycombed caps emerging where flames once cleared dense growth. Fire changes the chemistry of soil, releasing minerals and altering pH levels, creating conditions that favour these fungi. The fire does not summon them into existence. It simply clears space and adjusts the balance in their favour. What looks like destruction becomes an opening. These post-fire mushrooms do not hurry. They arrive when the ground is ready, not before. Their appearance can feel like reassurance, a sign that life has not retreated but rearranged itself. In these landscapes, fungi act as first responders, beginning the work of recycling charred material back into usable nutrients. Ash becomes part of the soil. Burned wood softens. The ecosystem starts its slow recovery, guided in part by organisms that never left. Cold presents a different challenge. In regions where temperatures drop below freezing, soil becomes rigid, water turns to ice, and plant growth pauses. Many organisms retreat or perish under these conditions. Fungi respond differently. Some species enter dormant states, their metabolism slowing until warmth returns. Others remain active even in cold soil, continuing to decompose organic matter at reduced rates. Certain fungi produce compounds that function like antifreeze, protecting their cells from damage as ice forms around them. These adaptations are not dramatic. They are chemical adjustments refined over long periods. In alpine regions and polar environments, fungi are among the most persistent forms of life. They grow slowly, often invisibly, sustaining ecosystems where few others can operate year-round. Lichens, partnerships between fungi and photosynthetic organisms, colonize bare rock in freezing climates, gradually breaking it down into soil. These communities endure cycles of freezing and thawing that would destroy more delicate structures. They do not resist cold, they accommodate it. What is striking about fungal resilience is how unforced it is. There is no sense of struggle in their adaptations. They do not push against conditions or attempt to dominate them. They simply shift their processes to match what is available. When fire removes competitors, they expand. When cold limits activity, they slow. When moisture returns, they resume. This flexibility allows them to persist across environments that fluctuate widely over time. Some fungi have been found thriving in places that challenge our assumptions about habitability, from arid deserts to radioactive sites, from deep underground to high elevations. In each case, survival does not come from aggression or speed, but from compatibility. Fungi adjust their chemistry, structure, and timing to fit the world as it is, not as they wish it to be. This quiet endurance offers a different image of resilience. It suggests that survival does not always look like resistance. Sometimes it looks like patience. Sometimes it looks like waiting without weakening. In ecosystems shaped by disturbance, fungi provide continuity. Fires will burn again. Winters will return. Storms will reshape landscapes. Through it all, fungal networks remain, ready to respond without alarm. They do not remember fire as trauma. They treat it as one more condition to integrate. Over time, this ability to endure without strain contributes to the stability of entire systems. Forests regenerate not because they avoid disruption, but because organisms like fungi are prepared for it. Soil rebuilds because fungi remain present when other life retreats. Nutrients cycle because fungi continue working when conditions are harsh. This persistence does not announce itself. It becomes visible only when new growth appears, when green returns to blackened ground, when thaw reveals softened soil beneath snow. At those moments, it is tempting to focus on what has emerged. But the real story lies in what never left. Fungi remind us that continuity does not require constant activity. It requires readiness. They embody a form of life that is comfortable with interruption, confident in its ability to resume. In a world shaped by cycles of stress and recovery, this approach has proven remarkably effective. Fire and ice come and go. The planet changes. Fungi remain, adjusting quietly, carrying life forward without urgency, without resistance, and without needing to be seen. Damage leaves marks on the land in many forms, some obvious and some invisible, and not all of it fades on its own. Oil seeps into soil and water, plastics fragment into smaller and smaller pieces, chemicals linger long after their purpose has passed. To human eyes, these wounds can feel permanent, as if the land remembers them forever. Yet fungi approach damage the same way they approach fallen trees or burned forests, not with judgment or urgency, but with chemistry and time. They do not recognize pollution as something separate from the rest of the world. They encounter it simply as material, and they respond with the tools they have evolved to dismantle complex substances. This process, known as mycoremediation, sounds technical, but at its heart it is simple. Fungi break things down. They have always done so. Oil, plastic, and synthetic chemicals are unfamiliar only to us. To fungi, they are just complicated molecules. Many species produce powerful enzymes capable of cutting apart long chains of carbon and hydrogen, the same kinds of bonds found in wood, leaves, and natural resins. Petroleum products resemble these structures closely enough that certain fungi can digest them, slowly converting toxic compounds into simpler, less harmful substances. In places where oil spills have darkened soil and water, researchers have observed fungal colonies spreading through contaminated ground, their mycelium threading into places machines cannot reach. Over time, the oil diminishes, transformed into carbon dioxide, water, and organic matter that other organisms can use. The process is not fast, it is not dramatic, but it is steady. Plastics present a newer challenge, but even here fungi show promise. Some species have been found capable of breaking down polyurethane and other stubborn polymers, using enzymes that soften and fragment materials designed to resist decay. These discoveries are still being studied not as miracles but as extensions of fungal behavior that has existed for millions of years. Fungi evolved to decompose the toughest natural materials on Earth. Given enough time, they apply that same persistence to what humans leave behind. What makes mycoremediation especially comforting is how little force it requires. There is no need for high temperatures, harsh chemicals, or heavy machinery. Fungal networks grow quietly through affected areas, responding to moisture and nutrients, adjusting their growth as conditions change. In some projects, straw or wood chips are added to contaminated soil to give fungi a familiar food source, encouraging them to expand. As they grow, they encounter pollutants and incorporate them into their metabolic processes. The land is not scrubbed clean, it is healed gradually, integrated back into functioning ecosystems. Birds return, insects follow, plants take root again. The transformation does not erase the past, it absorbs it. This approach reframes how we think about repair. Rather than removing damaged material and replacing it, fungi teach us how to transform it in place. The soil does not need to forget what happened to become fertile again. It only needs processes that allow change. Fungi provide those processes without requiring attention. They do not need to be supervised. They simply need time. This patience aligns with everything else fungi do. Just as they recycle fallen trees and endure fire and ice, they approach pollution as another form of complexity to be unraveled slowly. Their ability to adapt enzymes to new challenges reflects a flexibility that is deeply reassuring. It suggests that the planet is not as fragile as it sometimes feels. Damage does not always mean the end of function. Given the right conditions, repair can begin quietly without spectacle. There are places where this work is already visible. Former industrial sites treated with fungal remediation show soil slowly regaining life. Oil-soaked grounds become fields where grasses and wildflowers grow again. Contaminated wood is broken down into harmless components. These successes do not promise instant solutions to every problem, but they demonstrate a principle that has held true throughout fungal history. Life adapts to what exists. It finds pathways through complexity rather than avoiding it. This creates a gentle sense of hope that does not rely on optimism. It relies on precedent. Fungi have been repairing landscapes long before humans existed. They broke down volcanic rock to make soil. They recycled ancient forests again and again. Pollution is new in form, but not in challenge. It is simply another layer of material to process. This does not absolve responsibility. It does not suggest damage is harmless, but it does show that the planet carries within it the means to respond. Healing does not arrive as a reversal, it arrives as continuation. The same networks that recycle leaves and wood extend themselves into damaged ground, performing the same work at a different scale. This continuity is calming because it removes the sense of finality from harm. Nothing is beyond the reach of slow change. Even materials designed to last centuries begin to soften under persistent biological attention. The future shaped by fungi is not one of erasure, but of integration. What was once toxic becomes neutral. What was once unusable becomes part of soil again. This process mirrors how fungi treat everything they encounter. They do not distinguish between natural and artificial. They respond to structure, to chemistry, to opportunity. In doing so, they remind us that repair does not require perfection. It requires persistence. The land does not need to return to some imagined untouched state to function. It needs living systems capable of working with what is present. Fungi offer that capability quietly, without claiming credit. They do not announce success. They simply continue growing, dismantling, and redistributing, allowing ecosystems to reassemble themselves gradually. This kind of hope does not rush forward. It settles in gently. It suggests that while damage leaves traces, it does not have to define the future. Beneath polluted ground, threads grow, enzymes work, molecules shift, and slowly, without drama, the land begins to breathe more easily again. Long before fungi were studied or named, they were already present in the most familiar rooms of human life, working quietly on wooden tables, in clay jars, in warm bowls left to rest near a hearth. The relationship did not begin as science. It began as observation. Dough left alone would change, fruit juice would bubble, grains soaked in water would develop a scent that was both sharp and inviting. People did not know why this happened, only that it did, and that it could be encouraged or ruined depending on care. What they were witnessing was not magic, but partnership. Yeast, a single-celled fungus, had found a place alongside humans, and humans had unknowingly made space for it. Unlike the mushrooms that appear briefly after rain or glow softly in forests at night, yeast lives its entire life out of sight, microscopic and countless, feeding on sugars and releasing energy in the form of gas and alcohol. When flour and water are mixed and left alone, yeast begins to work. It consumes sugars and exhales carbon dioxide, filling dough with tiny pockets of air. Over time, those pockets stretch and hold, transforming a dense mixture into something light and soft. Bread rising is not an act of force, it is an accumulation of breaths, millions of tiny fungal exhalations expanding gently within a structure that can contain them. When heat finally arrives, the yeast dies, but its work remains, locked into the shape and texture of the loaf. The same process unfolds in wine and beer, where yeast converts sugar into alcohol and carbon dioxide, shaping flavors that have accompanied human gatherings for thousands of years. This relationship is ancient. Archaeological evidence suggests that fermentation was being used at least 10,000 years ago, possibly much earlier. Early humans may not have understood fungi, but they understood results. They learned that certain conditions produced reliable outcomes. Warmth helped, clean vessels mattered, time was essential. They learned to wait, to taste, to smell, to adjust. In doing so, they developed one of the earliest forms of biotechnology without ever naming it. Yeast became part of daily rhythm. Dough was mixed and left overnight. Liquid was sealed and stored until bubbles slowed. These processes fit naturally into human schedules because they required patience rather than constant attention. Fermentation happens best when left alone. This made it compatible with human life in a way that many technologies are not. You could go about your day while yeast worked quietly nearby. Even now, the presence of fungi in kitchens carries this sense of comfort. The smell of bread baking is inseparable from the idea of home for many people. The gentle hiss of a fermenting jar, the soft bloom of bubbles in a glass of wine, these are signs of life working steadily without noise or demand. Yeast does not hurry. It does not respond well to being rushed. Too much heat, too much sugar, too little time, and the balance is lost. Successful fermentation requires listening rather than control. Bakers learn to feel dough, to notice its elasticity, to recognize when it has risen enough. Brewers learn to watch airlocks and read subtle changes in aroma. These skills are learned through repetition and attention, not instruction manuals alone. In this way, yeast teaches the same lessons as its larger fungal relatives. Patience matters, conditions matter. Progress is not always visible until it is complete. There is also something quietly intimate about the fact that yeast lives everywhere humans do. Wild yeast floats in the air, settles on skins of fruit, rests on surfaces. Sourdough starters capture this presence, becoming small ecosystems unique to their location. A starter maintained in one kitchen develops different characteristics than one maintained elsewhere, shaped by local air, temperature, and care. People name them, pass them down through generations, carry them across borders. These living cultures become part of family history, sustained through routine rather than ceremony. This continuity mirrors the way fungal networks persist in soil and forests. The difference is scale, not principle. Yeast breaks down sugars just as larger fungi break down wood and leaves. Both release energy, transform material, and make something new possible. One works beneath trees, the other works beneath countertops. Together they remind us that fungi are not distant or exotic. They are woven into ordinary life. Even alcohol, often treated as a modern indulgence, is a product of fungal metabolism. Wine, beer, cider, and spirits all begin with yeast converting sugars into alcohol, a process humans learned to harness long before understanding chemistry. Fermentation likely made water safer to drink in early settlements and provided a way to preserve calories in liquid form. It shaped social rituals, trade, and agriculture. Entire cultures developed around fermented foods and drinks, many of which rely on fungi working alongside bacteria in complex communities. Cheese, soy sauce, miso, and many pickled foods involve fungal activity, often unseen and uncelebrated. The kitchen becomes a quiet extension of the forest floor, a place where fungi continue their ancient work of transformation under slightly different conditions. What makes this partnership especially soothing is its lack of drama. Yeast does not demand reverence. It does not require complex machinery. It only needs time, warmth, and food. In return, it offers nourishment, flavor, and preservation. This exchange has remained stable across centuries because it aligns with natural rhythms. There's no need to optimize it endlessly. Bread baked slowly tastes better. Fermentation allowed to finish fully develops depth. Rushing the process rarely improves the result. This stands in contrast to many modern systems that prioritize speed over quality. Fungi remind us that slowness can be productive. The presence of yeast in everyday food also connects us to generations before us. When bread rises on a counter, it repeats an action that has occurred millions of times across history. Different grains, different ovens, different hands, but the same underlying process. The fungi involved have changed little in that time. They continue to metabolize sugars the same way they always have. Humans change around them, but the partnership remains. There is comfort in that continuity. It suggests that some relationships do not need reinvention. They simply need maintenance. Even the language around baking and fermentation reflects this intimacy. Starters are fed. Dough is rested. Wine is allowed to breathe. These metaphors mirror care given to living things because that is what these processes involve. Life responding to conditions, growth emerging from patience. In the quiet moments of cooking and baking, fungi work alongside humans without ever being seen. They do not announce their presence, but their effects are deeply familiar. Warm bread, shared meals, simple pleasures. All of these are shaped in part by organisms that began their journey breaking down leaves and wood in ancient forests. The kitchen is not separate from the natural world. It is one of its many expressions, and in that space fungi continue to offer the same lesson they offer everywhere else. Transformation does not need urgency. Nourishment does not require spectacle. Life can work quietly and still shape everything we rely on. Before fungi were classified or studied, before enzymes and spores were named, mushrooms already carried meaning far beyond their physical form. Their way of appearing, quiet and sudden, their tendency to rise from dark soil without visible cause, made them feel like messages rather than objects. In many early cultures, mushrooms were not simply food or growths, they were signs. They arrived at moments that felt intentional, after rain, after storms, in places already charged with mystery, and people learned to pay attention to them in ways that went beyond usefulness. When a mushroom appeared where there had been nothing the day before, it felt less like growth and more like arrival. This alone was enough to shape belief. In landscapes where most plants followed predictable seasons, mushrooms broke the pattern. They did not wait for spring. They did not announce themselves with buds or leaves. They emerged whole, complete, as if placed rather than grown. For people whose lives were closely tied to land and weather, this behavior invited interpretation. Something that arrives without warning feels meaningful. Something that disappears just as quietly feels temporary in a way that commands respect. In ancient Europe, mushrooms were woven into stories of hidden realms. Fairy rings were thought to be places where the boundary between worlds thinned, where dancing beings gathered under moonlight. To step into such a ring was considered risky, not because mushrooms were dangerous, but because the space itself was different. Time might pass strangely there. Luck might shift. These stories did not portray mushrooms as evil. They portrayed them as threshold markers, signals that something unseen was present. In parts of Asia, mushrooms were associated with longevity and balance. Certain species were seen as symbols of endurance because they grew slowly, persisted quietly, and appeared in places shaped by age, such as old trees or deep forests. Reishi, for example, became linked with health and spiritual calm, not because it was common, but because it was rare and patient. Its presence suggested alignment rather than abundance. In Mesoamerican cultures, some mushrooms were regarded as sacred tools for communication, used in rituals meant to bring insight or guidance. These practices were approached with structure and restraint, not indulgence. The mushrooms were not taken lightly. They were part of ceremonies shaped by tradition, intention, and care. What connects these interpretations across cultures is not the specifics, but the tone. Mushrooms were rarely framed as ordinary. They were treated as intermediaries, not creators, but messengers of the Earth's deeper rhythms. This reverence was not based on superstition alone. It grew from observation. People noticed that mushrooms appeared when the land had been soaked, when energy moved through soil and air, when conditions aligned. They noticed that mushrooms often grew in places where decay and renewal met. Fallen trees, rotting leaves, old ground. These are liminal spaces, neither fully alive nor fully dead. It made sense then to associate mushrooms with transition, with movement between states. They embodied change without violence. They marked moments when the unseen became briefly visible. This symbolism persists even now, though it has softened into metaphor. Mushrooms still feel slightly out of place in modern categories. They are not plants. They are not animals. They exist between familiar groups, just as they always have. Science has explained their biology, but it has not stripped them of their quiet strangeness. Knowing that a mushroom is the fruiting body of a mycelial network does not erase the feeling of surprise when one appears. It deepens it. The earth speaks through processes, not words, and mushrooms are one of the ways those processes make themselves briefly known. The spiritual tone surrounding mushrooms was rarely loud or dramatic. Unlike towering trees or powerful animals, mushrooms did not inspire worship through size or strength. They inspired attention through subtlety. They required people to notice the ground, to look downward, to see value in what was small and temporary. In this way, mushrooms encouraged a form of humility. They did not dominate landscapes. They decorated them briefly and then withdrew. This pattern aligned well with spiritual ideas that emphasized impermanence and balance. A mushroom that appears overnight and vanishes within days embodies the idea that nothing is meant to last forever, and that this transience is not a flaw. It is part of the design. Many myths framed mushrooms as gifts rather than possessions. You did not own a mushroom patch. You encountered it. You took what was needed and left the rest. This approach reflected an understanding of reciprocity. The earth offered something briefly. Respect meant not overreaching. Even poisonous mushrooms played a role in this worldview. Their presence reinforced the idea that not everything is meant to be consumed, that discernment matters. Knowledge was passed down not just to identify what was safe, but to understand context, timing, and place. Mushrooms required learning that was local and embodied, not abstract. This further deepened their association with wisdom rather than utility. When modern science began to study fungi more closely, some of this reverence faded, replaced by classification and control. Yet traces of the old tone remain. We still speak of mushroom hunting as a quiet activity, one that rewards patience and attention. We still treat certain species with respect, even caution. We still feel a subtle shift when encountering mushrooms deep in a forest, as if we have stepped into a space where the land is momentarily expressing something about itself. This continuity suggests that cultural reverence was not misplaced. It was an intuitive response to organisms that operate on different rules, organisms that remind us that the world is layered with processes we do not fully see. Mushrooms do not explain themselves. They do not clarify their meaning. They simply appear, do their work, and disappear. In doing so, they invite interpretation without demanding it. This openness is part of their enduring power. They can be food, medicine, symbol, or sign depending on how they are approached. They adapt to human frameworks without losing their own nature. In a modern context where meaning is often loud and explicit, mushrooms offer a quieter form of significance. They suggest that not everything needs to announce its purpose to matter. The earth does not always speak in clear statements. Sometimes it offers brief appearances, subtle patterns, gentle reminders of cycles moving beneath awareness. Mushrooms have carried this role for as long as humans have noticed them. They rise from soil after rain, just as they always have, continuing a conversation that does not require words. They are not sacred because people decided they were. They are sacred because they reflect processes larger than human intention, processes that continue whether or not they are named. And in their quiet presence, they still offer the same invitation they always have: to notice, to pause, to accept that meaning does not always arrive with explanation. Long before forests covered the land, before trees learned how to reach upward and cast shade, the surface of the earth looked very different. Rock dominated the continents, bare and exposed, shaped by wind and rain but offering little foothold for life as we recognize it today. Plants had not yet learned how to stand tall or spread roots deep into the ground. Soil, as we know it, barely existed. And yet, life was already at work on land, quietly preparing the conditions that would one day allow forest to rise. That life was fungal. The earliest evidence suggests that fungi were among the first complex organisms to move from water onto land, arriving hundreds of millions of years before trees. They did not come to conquer or transform landscapes quickly. They came to persist. In those early ages, fungi partnered with simple plants, helping them extract nutrients from raw rock and mineral surfaces. The land was hostile then, lacking organic matter and protection from the elements. Fungi changed that slowly. Their mycelium crept across stone, releasing acids and enzymes that broke down minerals grain by grain. Over immense stretches of time, this process created the first thin layers of soil. Not rich soil, not fertile soil, but enough to hold moisture, enough to anchor early plant life. These early fungal networks were patient beyond comprehension. Millions of years passed with no visible forests, no animals walking above them, no seasons marked by falling leaves. Yet the work continued. Fungi do not require witnesses. They do not depend on results that can be seen within a lifetime. They operate comfortably on timescales that stretch beyond memory and imagination. As primitive plants slowly adapted to life on land, fungi were there to support them. This partnership became foundational. Plants gained access to nutrients locked in rock, while fungi received sugars produced through photosynthesis. Together, they altered the chemistry of the atmosphere gradually, increasing oxygen levels and setting the stage for more complex life. None of this happened quickly. There were no sudden transformations, just steady interaction repeated endlessly. The land did not bloom overnight. It softened layer by layer. When trees eventually appeared, they entered a world already shaped by fungal presence. Soil had been forming for tens of millions of years. Nutrient cycles were already established. The idea that forests simply emerged overlooks this long preparation. Trees did not create soil on their own. They inherited it. Fungi had already done much of the work. Even today, trees cannot survive without fungal partners. Their roots rely on mycorrhizal associations to access water and nutrients efficiently. This dependency is not a weakness. It is a continuation of a relationship that began before trees existed at all. Fungi did not step aside once forests formed. They remained, adapting to new roles, expanding their networks, integrating fallen leaves and wood into the cycles they had long maintained. When forests rise and fall over geological time, Fungi persist through every version. They witness the coming and going of entire ecosystems without needing to change their fundamental approach. This deep time perspective changes how fungi can be seen. They are not recent additions or background organisms. They are ancient participants, shaping the land quietly long before it looked familiar. Their patience is not learned. It is built into their nature. They do not hurry because there has never been a reason to. The earth has always changed slowly at its deepest levels, and fungi evolve to match that pace. Thinking about this can feel grounding. It places human history into a much larger context. Civilizations rise and fall in a fraction of the time fungi have spent preparing soil, recycling matter, and supporting life. Even forests, which feel timeless to us, are relatively recent in the planet's story. Fungi have lived through ages, when the land was empty, through the rise of forests, through mass extinctions, ice ages, and warming periods. Through all of it, they have remained present, adjusting quietly, continuing their work. This longevity gives fungi a certain weight. They are not fragile, they are not easily erased. Their networks may thin or retreat during extreme conditions, but they endure. They reappear when circumstances allow. They do not need to reinvent themselves because their role has always been essential. They prepare, they recycle, they connect. These functions remain relevant no matter what form life takes above them. When we walk through forests today, it is easy to feel as though trees are the elders of the land, the oldest living witnesses. But beneath them lies something older still, something that remembers a world before shade, before leaves, before roots that reach deep. Fungi carry that memory not as stories, but as structure. Their enzymes, their partnerships, their growth patterns are all shaped by that deep past. They are living records of Earth's long preparation for complexity. This does not make fungi superior, it makes them foundational. They are guardians not in the sense of watching or protecting intentionally, but in the sense of maintaining continuity. They hold together cycles that would otherwise collapse. They ensure that change does not erase what came before. They allow the land to remain capable of supporting life through vast spans of time. There is something calming in knowing that beneath modern landscapes lies a system older than forests themselves, still functioning, still patient. The ground beneath you is not just dirt. It is the product of millions of years of fungal activity, of slow interactions between life and stone. Every step rests on that history. And yet, fungi do not ask to be acknowledged. They continue their work whether or not they are remembered. Their presence is quiet, their influence immense, in a world that often feels focused on the immediate and the urgent. Fungi offer a reminder of another way to exist, one where importance is measured not by visibility, but by persistence, one where success is not speed, but continuity. They have waited through ages without forests. They have supported the rise of trees. They will remain long after many familiar forms of life change again. And in that long, steady presence, they hold the land together, patiently, without ever needing to be seen. The idea that fungi might accompany life beyond Earth does not begin with rockets or distant planets. It begins with noticing how comfortably they exist at the edges of what seems possible. Long before humans wondered about space travel, fungi were already thriving in places that feel almost alien, in deep caves with no light, in frozen soils where liquid water appears only briefly, in scorched landscapes where heat has stripped away most signs of life. These environments taught us something important without ever meaning to. Life does not need ideal conditions to persist. It needs pathways, patience, and the ability to adjust. Fungi have refined these traits over immense spans of time, and because of that, they have quietly entered conversations about places far beyond forests and fields. When scientists began testing organisms in space, exposing them to radiation, vacuum, and extreme temperature swings, fungi were among those that endured longer than expected. Some species survived outside spacecraft for extended periods, protected not by shields or technology, but by their own cellular structures and pigments. These pigments, often dark and dense, absorb radiation rather than being damaged by it, allowing the organism to persist where other life forms quickly degrade. This is not resistance in the dramatic sense, it is accommodation. The fungus does not block the environment, it adapts to it. In microgravity, fungi behave differently, but they do not stop growing. Their networks still form, their cells still divide. The direction may change, the structure may adjust, but the underlying processes continue. This quiet flexibility makes fungi interesting candidates for future exploration, not as travelers themselves, but as companions to human presence. The question is not whether fungi want to go to space. It is whether their natural tendencies make them useful wherever humans go. One of the challenges of long-term space travel or habitation is waste. Everything humans bring into closed systems must be reused, recycled, or stored. Fungi already specialize in recycling complex material into simpler forms. Food waste, plant matter, even some synthetic materials could potentially be broken down by fungal systems, reducing the need for resupply. Another challenge is building. Transporting construction materials across vast distances is costly and limiting. Fungi, however, can be grown. Mycelium can be encouraged to form dense, lightweight structures that harden when dried, creating materials that are strong, insulating, and biodegradable. These materials are already being explored on Earth for sustainable architecture. In space, where resources are precious, the idea of growing structures rather than assembling them piece by piece carries a quiet appeal. There is no urgency in this vision. It does not imagine cities springing up overnight on distant planets. It imagines slow establishment, careful use of what is available, and systems that support themselves over time. This approach aligns closely with how fungi have always worked. They do not impose form quickly. They grow into it. They do not dominate environments. They integrate with them. The same qualities that allowed fungi to prepare soil before forests existed make them suitable partners for environments that are still forming or unfamiliar. Even the idea of protection comes into play. Some fungi have been studied for their ability to shield against radiation, their dense structures absorbing harmful rays. In space habitats where exposure is a constant concern, fungal layers could contribute to shielding in ways that are lightweight and renewable. Again, this is not about heroic solutions or dramatic breakthroughs. It is about quietly extending natural processes into new contexts. The deeper connection lies in continuity. Fungi were among the first organisms to help life move from water to land. They supported that transition by preparing ground, recycling material, and forming partnerships. In this sense, they have already acted as pioneers once before, not intentionally, but effectively. The thought that they might support another transition, this time beyond Earth, carries a gentle symmetry. It suggests that the same principles that allowed life to spread across continents might one day help it move farther still. This does not turn fungi into symbols of conquest or expansion. It frames them as facilitators of adaptation. Wherever conditions are difficult, wherever systems need to become self-sustaining, Fungi offer tools refined by deep time. They do not promise comfort, they promise continuity. There is something calming in imagining the future shaped by organisms that do not rush, that do not seek dominance, that do not require perfection. Space is often imagined as harsh and unforgiving, but fungi remind us that life does not need to overwhelm environments to persist in them. It can arrive quietly, test conditions, adjust, and wait. This perspective shifts the tone of exploration from ambition to patience. It suggests that if humans do move beyond Earth, they will not do so alone. They will carry with them ancient partners whose way of living is already suited to uncertainty. Fungi do not see environments as hostile or friendly. They respond to what is present. In that sense, space is simply another context, another set of conditions to work within. The wonder here is not in imagining distant worlds transformed quickly, but in recognizing how adaptable life already is. The same networks that glow softly in forests, recycle fallen trees, drift through air as spores, and rise quietly in kitchens could one day extend their work into places where no soil yet exists. This does not diminish the mystery of space, it grounds it. It reminds us that the universe is not separate from the principles that govern life here. Matter behaves consistently. Chemistry repeats patterns. Given time and opportunity, life explores those patterns without needing intention. Fungi embody that exploration without spectacle. They do not announce new chapters in the story of life. They simply continue it wherever they find a place to grow. Thinking about this does not require excitement or anticipation. It can be held gently, as a possibility rather than a plan. Past pioneers becoming future ones, not through choice, but through suitability. Ancient organisms carrying ancient strategies into unfamiliar settings. The universe, vast and quiet, meeting life that is equally quiet and patient. The idea does not ask us to imagine dramatic futures. It invites us to notice continuity. The same processes that shaped forests, soils, and kitchens remain available wherever conditions allow them to operate. In that sense, distant worlds are not entirely distant. They are part of the same material story, waiting for the same slow, careful work to begin. As everything settles into stillness, it can be comforting to imagine what continues beneath you, unnoticed and unhurried. Beneath floors and soil and stone, beneath roots and paths and quiet rooms, threads extend softly in every direction, touching and passing and resting where they need to. They do not rush, they do not stop. They simply continue, doing what they have always done, shaping the ground slowly enough that nothing needs to be forced. Each breath you take moves air that has brushed forests and fields, that has lifted spores and carried them gently onward, part of the same circulation that has always connected distant places. Somewhere far away, mushrooms glow faintly in the dark, not to be seen, but to exist, steady and calm. Somewhere else, fallen leaves are being turned back into soil, molecule by molecule, without sound or urgency. This work does not pause when you rest. It becomes quieter, slower, more evenly paced, matching the rhythm of the night. If you like, you can picture the ground beneath you as layered and alive, held together by networks older than forests, patient enough to wait through centuries, adaptable enough to follow life wherever it goes. Nothing down there is hurried, nothing is lost. Everything moves in cycles that have room for rest. You are part of that continuity simply by being here, by breathing, by letting your body settle the way the land settles after rain. There is no need to hold on to thoughts or follow them anywhere. Just as fungi trust the world to carry their spores, you can allow the moment to carry you towards sleep. The planet continues its quiet work whether you watch or not, and you are safe within that steadiness. From Boring Planet, thank you for spending this slow journey with us. Wherever you are and wherever your thoughts drift next, the quiet pulse beneath you remains, patient and constant. Sleep well.